Hello everyone. In this video, we'll try to determine the reactions of a cantilever beam. So you can see this is a cantilever beam. One side it is fixed and another side it is free. Its total length is 12 meters and it has a varying load of at one end it is 15 kilonewton per meter and on the other end is 5 kilonewton per meter. We already know that since this is a fixed end, we'll get three reactions here. That is a reaction in horizontal direction, a reaction in vertical direction, and a moment in an anti-clockwise direction. Now, since this is neither a UDL nor a UVL, so it is a combination of UDL and UVL. First, what we'll do is we'll try to distinguish or differentiate the different type of loads acting. So first, we'll take a UDL where we can see here the 5 kilonewton per meter is acting toward the beam. And another type of load is UVL, uniformly varying load, where here it is 0 and here it is 15 minus 5, that is 10 kilonewton per meter. Now we'll try to convert this in terms of like point loads. To find out the point load, it's a simple, if it is a UDL, we just need to multiply with the distance into the intensity acting, that is 5 kilonewton per meter, and the total distance, that is 12 meters. So it gives me like 60 kilonewtons. Whereas in the UVL, since it is in type of a triangular shape, we need to apply the triangular area formula, that is half into base into height. So we have drawn half here, base is 12 meters and height is this height, 10 kilometer per meter, that is intensity. So it gives me 60 kilometers. Now we got the magnitude, but we need to find out the direction. We don't know exactly the resultant. Whatever we got 60 kilonewton here and 60 kilonewton, where exactly it is acting. So to find out if it is a UDL, since it is similar to the CG of a object. So this UDL seems to be a rectangular shape. So the CG of the center of gravity of the rectangle acts at the exactly center. So that is distance by 2. So this is x by 2. X is nothing but my overall length, that is 12. 12 by 2 gives me 6 meters. For this, since it looks like a triangle, in the center of gravity will act h by 3 from the maximum intensity and 2h by 3 from the minimum intensity. So since we are trying to find the moment from maximum intensity, it will be h by 3. H is nothing but overall length is 2h by 3. Gives me 4 meters. Now we have converted this UDL into point load and UVL into point load. Now let us find out the reactions of this cantilever. To find out the reactions, the first and foremost conditions which we need to fulfill is the equilibrium conditions. What are the equilibrium conditions we have? All the horizontal forces are equal to 0, that is sigma fx equal to 0, sigma fy equal to 0, all the vertical forces will be equal to 0, and all the moment with respect to a point will be 0. So we'll start with the first equilibrium condition, that is sigma fx equal to 0. As you can see, there are no horizontal loads are acting here. So Ax will definitely become 0. Now coming to the second condition, that is sigma fy equal to 0, we need to equate all the forces acting on the beam. So now we consider the upward direction as positive and downward direction as negative. Here we have resolved this. This is Ay reaction. It is acting upwards, so we took positive. And what are the different other loads acting? So we have converted this complex load into equivalent point loads, that is 60 kilonewton downwards and 60 kilonewton downwards. So since downwards is negative, minus 60 due to UDL and minus 60 due to U equals to 0. When we simplify it, the end result we'll get is 120 kilonewton. Now the third equilibrium conditions, we got just Ay, we know X, but we need to find out what is my MA, moment acting at the point E. For that, we need to take the moment with respect to E. So we'll start with the right hand side. So moment is nothing but load into distance. That is what moment is. So we'll start with the nearest one, that is 4 meters. The first one is 60 kilonewton is acting at a distance of 4 meters. So I have written 4 meters. So since this is downwards, so it is negative. The other far distance which we have is 6 meters. So a 60 kilonewton is acting due to UDL at a distance of 6 meters. So 6 meters. Plus on the left hand side we have a moment reaction rate and it is acting in the upward direction anti-clockwise. So that is M positive. So when we try to solve this, the moment which we got is 600 kilonewton meter. So this is how we find out the reactions for a cantilever. Hope you all understood it. Thank you.